recording? Are you recording? Okay, good. This is Work Hardening 101. So we've been given a series of wires, some copper wire. I've straightened this to the best of my ability thus far. This is some bent up material. We're going to talk about what happens when this material bends. So normally when copper is produced, it's soft and it's very malleable. It bends fairly easily. But when we bend that wire, something happens in the grain structure. If we bend it a lot, frequently, if we hammer on it or beat it, put physical work into it, what happens with the grains is they smash down, and as a result of that, they get stiffer. So the grains start out, they're nodular. That's a technical term for the kind of roundish or like grains of sand. They nest together like this. And as we work them, if you do this with your fingers along with me, as we work those, they get forced away or kind of stuck against each other. So normally they nest in nice like this when they've been annealed, heated, and then cooled or quenched. And then if we bend that, it kind of gets broken like this. And when we try and bend it back, the fingers don't necessarily go back together like this. They kind of fight against each other and they stretch or deform, but they also get more rigid. So I can see that in metal. If I bend a certain location of my copper and then try and bend it back, it doesn't want to bend back in that area. This is already work hardened. And you can try that yourself and see it happen. I can add or put some more force into it, but it's going to take more energy than I originally put in to get that to go back straight. And then I end up getting these little whips or waves in it. What I'm going to ask you to do is to take that piece of copper that you got that's wrapped up like this and just try and straighten it. Find the areas that you need to manipulate in order to get it as straight as possible. While you're doing that, I want you to sight down it, which means you're going to look down it like this, and you can see right now I've got all kinds of twists and whips in this that I can try and work out. I also want you to take the end and I want you to work harden a piece. So get your fingers like this and bend it back and forth a number of times, and you'll notice it gets exponentially harder to bend after I've bent it the first couple times. Most of your wires are going to do this. Your black mild steel wire, which I'm going to grab and just show you that too. So if I take some of this mechanics wire and do the same thing, if I bend it a number of times, it's going to get stiffer. If I keep doing that though, it's a lot more work. I can put a lot of work in it, and I'm stressing those materials so much that they're basically forcing themselves away. And I can elongate those or stress them out, right, until they fail. So you can try that with the mechanics wire, see if you can get it to break. It takes a fair amount of finger strength. When we get our pliers, you can do it with pliers very easily and basically stress fatigue that. This example here is, I'm just showing you like the wire, if I bent it up like this on a microscopic level or looking very closely. So if you can imagine this as a microscope, this is what we're seeing, right? This is our wire. We have a microscopic level. We're creating fractures in here, and these fractures or fissures will actually end up going all the way through the material, and then we get a failure, something like that. So a little bit on work hardening. What we're going to do with this is just practice a little bit in straightening our material and understanding what's going on with that metal at a molecular level or a grain level, grain structure level when we put work into it. See.